Hi, Chris Good here, and this is a lecture on the repeated measures or related samples t-test. Up to this point, we've really only been considering the independent samples t-test, which is used to determine whether the difference between two sets of scores is significant. We're dealing with two means, the mean from one group and the mean from another group. And with the repeated measures or related samples t-test, we're not dealing with two sets of scores, even though we have two scores from each person in a repeated measures study. We're dealing with one set of different scores. Let's go back to our familiar example of the ginkgo. We're going to see if ginkgo improves your memory, comparing it with the placebo. In the independent samples method, we had one group of people taking placebo, one group of people taking ginkgo. A repeated measures version of that study would involve the same number of people, and here we see 5 people, taking ginkgo and also taking the placebo. We'd have to do this at different times, and you can see another lecture about the importance of counterbalancing these two, the order of these two different treatments. So you might assign some of the people to take ginkgo first and placebo second, some of the people to take placebo first and ginkgo second. At any rate, if you do the study, you'll end up with two sets of scores for each individual participating in the study. One set of scores from when they were in the control condition, and the other set of scores from when the same people were in the treatment condition. And we would calculate some different scores simply by subtracting one score from another. It doesn't matter which direction you do it in, as long as you do it the same for every individual and as long as you keep track of what that difference means. Here, I've subtracted the control score from the treatment score so that when we get a positive difference score, it means their score was higher under the treatment condition. You can see for every individual here in these fake data, everyone's score was higher when taking ginkgo than when taking the placebo, when taking the treatment than when taking the control. Whereas in the independent samples t-test, we want to know if the difference between two sample means is significantly different from 0. In the repeated measures or related samples t-test, we want to know is the average difference score that's of that single set of difference scores that we just calculated. What's the average difference score, which we write mean m sub d? Is it significantly different from 0, or is it sufficiently close to 0 that you don't see an effect? So we do this as a null hypothesis significance test. T is calculated very similarly but slightly differently from the independent samples t-test. We're really seeing if the average difference score in our sample, if that is significantly different from 0. So T then is equal to our sample mean difference score, which we get by subtracting in the same direction to get a set of different scores and then taking the average of all those different scores. We subtract a hypothetical population mean difference score, which we write mu sub d, and divide it by the estimated standard error of the mean difference score. I'll tell you what that is later. So if we're doing this as a null hypothesis, where the treatment doesn't have any effect, where ginkgo doesn't do anything, if that's true, then in the population, where you take everybody's score who took ginkgo, and you subtract those same people's scores when they were taking the placebo, if ginkgo doesn't do anything in the population, what should the population mean difference score be? It should be 0. And so we're able to substitute in a value of 0 for mu sub d in the t equation based on that null hypothesis. Null hypothesis is always that your treatment had no effect. Mathematically, in the independent groups t-test, independent samples t-test, we hypothesize that the difference between two population means is 0. Here, it's only one population mean we're concerned with and only one sample mean. It's not that we hypothesize the difference between the sample mean and the population mean is 0. It's that we hypothesize that the population mean difference score is 0, and we want to test to see whether our sample mean difference score is significantly different from 0. How do we go about doing that? Well, there's a set of equations T is pretty simple. You know what the mean difference score is. Population mean difference score is 0. So all that's left to calculate is the denominator. The estimated standard error you'll find is very much like the estimated standard error of the difference between two sample means, as in the independent group's t-test. But it's even more simple. It's the square root of the variance of the different scores divided by the number of different scores. Square root of that whole quantity. How do you get the variance of the different scores? Variance is simply sum of squares over degrees of freedom, except it's the sum of the squared deviations of each difference score from the mean difference score. Right? So we take all the deviations of the mean difference score, which we calculated back here, right? This mean difference score of 1.2, do the deviation. 2 minus 1.2 is 0.8. 1 minus 1.2 is negative 0.2. Same for these. And if you add those all up, those deviations, you'll get 0. But if you square them, then you'll find that you get a non-zero value for this quantity, the sum of the squared deviations for the different scores. The degrees of freedom for the different scores in the denominator of the estimated, of the variance of the different scores, degrees of freedom, df sub d, is in the denominator of variance for the different scores. That's just the number of different scores minus 1. So that's the variance. Plug that in to get estimated standard error. Plug that in to get t, and you're done. Cohen's d is a slight modification. You take the mean difference score and divide it by the square root of the variance of the different scores, and r squared doesn't change at all. Everything else still applies in terms of null hypothesis significance testing. We go through our regular steps. We state the null, in this case mu sub d equals 0. We set alpha, usually in my class it's 0.05, two tails. You look up t-crit based on the degrees of freedom that's equal to the number of different scores minus 1. Calculate your t as per the equation on the previous slide. Make your decision with respect to the null hypothesis, retain or reject. And in my group, you write a complete sentence, starting with capitalized word and going all the way to the end, but make sure that you include t, degrees of freedom, and p, expressed as an inequality, as part of that sentence. That's pretty much it for repeated measures t-test, and I'll see you in the next lecture.